A system of inequalities graphically, what we do is two of the linear system problems that we've done before separately onto the same grid. And then what we're looking for is a point in the solution set. Now, the solution set is going to be the overlap of the shaded region. So we're looking for a shaded overlap. So any shading overlap is where our solutions will be. Now, there's a little more to it than that because then there's a solid line and then there's a dashed line happening. We're going to see stuff happening about what happens on the lines and all that. But anything that's in the solution set, we're gonna identify that at the end. So first thing we want to do is reference back to our idea that this means you shade below. Y is less than is a shade below. And because it's a solid line here, we're shading below a solid line. And then because this one is a less than, we're going to be shading below. And it's going to be below a dashed line. So we're going to go ahead and graph each of these lines independently and then come back and discuss how the solution overall is affected by the two separate graphs. So let's start with the first one. We use mx plus b form. This is the b value of 3, so I'm going to start at the y-intercept of 3. And from there, I'm going to use the slope, the m, of -1. So -1 means I go down 1, right 1 from this dot, and down 1, right 1 as many times as I like. And so I go ahead and click that in there. So I click this first dot, go down 1, right 1, click the second dot, and I've got this graph. Now, this is not the inequality yet because I haven't added any shading, but it is the right graph of the line because it's supposed to be an equal to solid line. So now I just click shade, change shade, and the first shading presents me as incorrect because it is currently shading above. If you're shading up, you're shading above. That is not where I want to be. I want to shade below, which is shading to the negative y's below. So I click again, change shade, and now it's shaded the right direction. Now I'm done with that line. That line has been done correctly. If I make any mistakes, I can actually go back to it, but I got to notice that it's being highlighted right now, which means I'm currently impacting this line. So let's graph the second one. The second line starts at -6, the y-intercept. So I go down to -6, click a dot in there. And from that, I'm supposed to rise 1, run 2. Slope of up 1 over 2. Up 1 over 2. Any of those points along there, I click those and I will get my line. So I click at -6, rise 1, run 2, and there I am connecting those dots. Now, pay attention to the fact that this is supposed to be a dashed line. That's what I had referenced before. That's going to be shaded below. So I click change line. Now it's dashed. And then there's some shading over here to the left, but it's above and below the line. That's because it's from the first line I graphed. Notice also that I got this new icon here that says line 2. I can change it and go back and talk about line 1 if I needed to, but I want to fix line 2. Change the shading to be below. If I accidentally did it above, I'll get the wrong answer. I want to shade below. Now, what I'm looking for overall is the set of solution coordinates that are double shaded. And that's in this region here where you see that this is light purple, light green, and this is a dark green purple. Any coordinate down here, any of these dots, anywhere in between dots, all of them, these are all solutions. Anything up here is not a solution. Even though it's shaded only once, it's just a solution of one of the lines, not both for the full system. So this is not a solution. These are definitely not solutions. And then anything over here is not a solution. Now, on this dashed line, these are not solutions. So these are not solutions because they are not included by this line. This line here, the solid line, the solid boundary of my double shaded region, those do count as solutions. Any dot on that line would be a solution. And then finally, Let's talk about this dot right here, the intersection. Because on the one line it's dashed and the other line it's solid, the dashed overrides. This is not a solution dot right there. So it would work in the one equation and not the other one. So the point is that any of these dots, what I just said was I could pick one of these, and these dots would work in both systems. So let's pick this dot 0, -9. If I took 0, -9, here, I would quickly see it's a true statement. So this said that all the y's would be less than -x plus 3. So if I took my coordinate that I just identified down below as 0, -9, I said this is supposed to work in both. So I plug in -9 for y, and then 0 here for x, and sure enough, -9 is less than 3. And I could try in the second one. -9, plug a 0 right there. -9 is less than -6. So all that I'm really doing is figuring out where are all the solutions that are true if I plugged it into both inequalities. They would make a true statement. And so you're just having to pick any singleton. So I could pick 0, -9. I could pick 0, -1,000. I could pick this coordinate right here at -4, -10. -4, -10 is a answer, a solution. Any dot, -10, -10 is a solution. Or sorry, +10, -10. 10, -10 is a solution. Any of these coordinates in here work. This coordinate right here at 5, -5 is a solution. Any dot in my double shaded region is what I'm looking for. So you put any one of them in here, 10, -10. That'll work. Now we're going to get a scenario where we have y is greater. Anytime we have y is greater, that means you shade above. And then above what? Well, this has a solid line, so we're going to be above a solid line. And then this one here is going to be shading above also. And there is no solid line underneath there, which means we're going to be shading above a dashed line. Then we'll get shading, and the point in the solution set is what we have to name any point in there. And the solution set is the overlap. The overlap shaded region is what we're going for. So we'll graph both of these one at a time. So we're going to start with the +3, the y-intercept at 3. And from there, we're going to have a slope of -1. So from that dot, we go down 1, right 1, down 1, right 1. And that's going down slope of 1. So click any dot here, down 1, right 1. And on that line right there, we are to keep it solid, but then shade above. So don't change the shade, change the line. If you change it dash, make sure you change it back. And then change the shade to be above. And sure enough, above is pointing up to the positive y's version of the y-axis. So the positive y side of the y-axis is what I meant to say. And then down below, I'm going to shade and draw my second graph. So I need to start at the y-intercept of -6. So click right here. My slope is 2. So I'm going to rise 2, run 1, rise 2, run 1, and then click a dot. Click any of these dots that I just counted out, and I see that it intersects there at 3, 0. That's actually not a point that's actually a solution, but it does intersect there because I'm supposed to now change the line to be dashed. So I click change line, and then I want to shade above. So I click change shade. This is shading below. So I change it again. Now it's shading above. And you can see my solution set is any coordinate up above where there's double shading up in here. So these are all solutions up here. Anything on this line, this solid line, is a solution. So these are all good up here. This is good. Anything on this dashed line is no good. Anything in this single shaded, no good, no good, no good down there either. So anything in the double shaded region. So I'm going to click any single dot, pick it, and it would work in both equations up here. So if I picked 0, 7 and plugged it into this equation right here, 7 would be bigger than 3. If I plugged in 0, 7 to this one, 7 would be bigger than -6. It's true in both inequalities. And that's the whole point. This is the infinite region of dots. There's infinitely many dots up here that work in both expressions. So you just pick one and put it down here. So I could pick 0, 3, or I could pick 0, 10. I could put 3, 3 right there. 3, 3 will work. Any of them. Pick one. All right, one more to solidify. We've got a less than. So this is going to be a shade below scenario with a solid line. So we're shading below a solid line. And then we have to shade below again. And this time it's a dashed line. So we're going to start at 7. And then our rise over run is -3/5. So I'm going to go down 3. 1, 2, 3, right? 1, 2, 3, 4, 5. And connect those dots. That should be a solid line, so we leave it alone. Shade below it. And that one's done. And then we're going to do the other one. Start at -6. I'm going to rise 2, because my slope is 2. Run 1, up 1, 2, over 1. Connect those two dots. And then I need to change that line to be dashed. And then I need to change the shading to be below. And then now I have my region of overlap. I just identify any point in this double shaded region. And 7, 1 looks good to me. 7, 1. Throw that down in there. And I'm done. So this is how you find the solution set and a point in the solution set for a system of inequalities.